Hello everyone. In this tutorial, I will be introducing you to PySpark and how you could use it on your daily tasks. So I'm going to provide you a brief introduction of Spark and how you could apply PySpark. In my introduction section, I'll be talking about Spark as a stack, Spark shell, and how it interrelates with PySpark and the uses of Spark. In the application section, I'll show you how to install it, how to use Spark context, data load time comparisons, going from pandas to Spark, some data frame operations, and also how to use Spark machine learning. To start off, there is something called Spark Core. Spark Core is the underlying engine of Spark. Some functionalities of Spark Core is dispatching, scheduling, input-output operations, and algorithm operations. With Spark Core, there's something called RDD, Resilient Distributed Dataset. I will talk about a little bit in the subsequent slides. Along with Spark Core, there are some associated subpackages that use it. On the picture on the right, you see Spark Core as the bottom layer and Spark SQL, Spark Streaming, Machine Learning, and MLlib as packages on top of Spark Core. At the top images, there's some different implementation of Spark. It could be a standalone using Hadoop with Yarn or Mesos and just Hadoop MapReduce. I'm going to provide you a brief introduction of PySpark and how the shell is the connection between Spark and Python. PySpark shell exposes the Spark programming model to Python. The PySpark shell links the Python API to the Spark's core and initializes the Spark context. PySpark shell also supports connecting to a cluster if you have a very strong cluster computing system. Spark context, what is it? It's an entry point or a master Spark application. Any process or command I want or the user wants to execute goes through Spark context. Spark session is something new as a Spark 2.0. It is basically an entry point if you have several users in Spark session and also instantiate the Spark context. So you could think of Spark session as below Spark context. Here in the image on the right, you see Spark context, how it communicates to the local file system, as well as the cluster compute. So Spark. Spark has several data structures that anyone can use. I believe I introduced it a little earlier, RDD, Resilient Data Frame Data Structures, is a fault-tolerant collection of elements that can be operated in parallel. In the picture on the right, you see how the RDDs, what is that? It basically takes the original data frame and splits it up into several smaller data sets. So no data is lost in the ingestion. In 2013, data frame was introduced with Spark. Data frame is a data set organized in columns. It is very similar to the relation dataset model and also data frames in Python and R. Also has some great optimizations under the hood. Something that's not available for PySpark is dataset, and that was released in 2015. That uses type safe, which is basically introduces the RDD model and also increases the speed. With RDD, there's two types of operations: transformations and actions. Transformations takes the original RDD or multiple RDD and brings them into one or many RDDs. Actions basically take all the RDDs and apply an operation to all of the RDDs. Here are some examples of transformation and actions. I'm not going to go through all of them, but some big transformations are union and group by key and reduce by key. Union basically takes two data frames and combines the RDDs on the same schema or the same key. There's some transformations where you could do on just RDDs alone, not data frames, and those are listed below. Some actions you could do on RDDs are collect, take, reduce, save as text, and count by key. These are mostly on the RDD side of it, so not data frame. So the picture on the right really displays what I mean by RDD. So take a look at the RDD section. In order to make an RDD, you would take some sort of text file and assign it to text file, and then from text file, in order if you want to do some sort of lambda function, you filter lambda function like I was saying here. You can make a transformation on all the RDDs to make a new RDD essentially to filter for the word Spark. If you want to do an action on all the RDDs, you could count all the RDDs, or you could see what was this first value in this RDD. And this example, we're basically doing transformation and then action. So you see line of Spark, line of Spark. All right, so now I'll move towards PySpark and how to use it. The first step of PySpark is to install it on your local machine or on your Jupyter notebook. If you're on your local machine, you would do it via the command line, or if you're in a notebook, you would use the exclamation mark. So the first step, like I was saying, is to instantiate a Spark context. Spark context was the version 1.0 to open the door of Spark. It's very simple. All you have to do is import from context, import Spark context module. What this does is allows you to make a Spark context which you could use. So one caveat is you need to make sure you stop the Spark context before creating a new one. So you can't just make a Spark context every time you want to do an operation. You have to either do it once and use it as a variable, or use it with the with statement. Here you can see the Spark context version, also the Python version, and to see where you're running the Spark context, either on the local or a cluster compute. If you want to do a cluster, you would use the first variable assignment, and you would either show where it is on a cluster or your host import. I believe their Databricks has a very nice cluster kind of setup you could use. So here's a comparison between PySpark and your local machine. I made a 10 million row text file, which took about 4.6 seconds. I compared how long it took to load with Spark, as well as the local machine. As well, again, you have to make sure you initialize the Spark context. You load it using the text file function. You collect all the elements from all the nodes of the RDDs, and then I just stopped it. Same thing with the local file system. You don't have any collection from all the nodes. You just do the read function to read everything. And that took a fraction of a second, while this took several seconds. I believe this happened because you're using the Python API, as well as the Colab RDDs are a little more trickier. So if you have a faster cluster compute, it would be a lot faster. Okay, so next operation I did was going from Pandas to Spark. Many of us use Pandas on a daily basis, so I want to show how easy it is for you to go from Pandas to Spark. As normal, you read CSV from your file path, and then instead of doing another frame, you have to use Spark that create data frame to on the Pandas data frame, and then you could see the data frame as a Spark data frame. All right, it's pretty simple. Next operation, I want to show you how to use Spark Session. In a previous slide deck, I showed you how Spark Session was below the Spark context. So if you have several users, each user could make a Spark session. and connect to a specific context. Here it is. You again use a Spark session, initiate it using, and then build it, and then create it. In my next slide, I'm going to show you how you can name it, but here I didn't name it. You see how the Spark context is an attribute of the Spark session. So again, same thing, Spark shell, Python, and also it's running on a local machine. So here is an example of me doing some sort of actions on a data frame from Spark. So first step is to create a Spark session called Spark, load it using the read.csv method, and then print the schema as you saw before. And I showed the data frame first 2 rows. And then to filter using Spark, you use the dot filter method, which is a transformation. And then you show it again. So here is an example of a transformation of a data frame. Next, I did a selection, also a transformation, just subsetting a couple columns. It's just very simple. And here I did an action on the original data frame. Here you see the max of all the columns. In order to do that, you have to first do a group by and do a max, and then a show to see it. Pretty simple as well. Finally, I did a group by. So this is doing a transformation as well as an action. So my initial transformation was group by, and then I applied an action as well as another sort of transformation as sort, but nothing, no major change, so it's not a transformation. So it's just, yeah. But as you can see here, first step is to group by lat head long, and I want to see if median income, the average of median income has an effect on the median house value. As you can see, it does. The higher the median income, the higher the house value. As you can see here, you could also see which areas have these high house values, and these are also the averages of these houses. Next, I'm going to show you some machine learning methods. Here is a basic outline of how to run a linear regression model. With pandas, it's a little different. You keep all the original columns as is, and you load it to your, your instantiated linear regression model. But with Spark, it's a little different. You have to make all the columns into a vector, and then you use that vector as your features for your linear regression. So the PySpark.ml.feature has a vector assembly method with which could or a function which will take your original data frame and make an output of it. So here I made it independent, and then I'm going to transform my original data frame using the independent function I made. And as you can see here, I made a new column or a new feature, which includes all of my features for my model. And then in order to make it ready for the next step to instantiate the model, you have to subset your original data frame with the vector assembly feature as well as the target. Next step is to instantiate the linear regression model. So here's the package you bring in, and then you instantiate it using linear regression, the column, which is the features, and also the target value, which is label column. Then you fit it as normal, and this will allow you to instantiate your linear regression model. Now I'm going to evaluate my model. I'm going to look at the the coefficients of each of my variables as well as the intercept. As we saw before, the median income variable has the most effect on the house value, on the house value. Next, in other features, as you see here, total bedrooms household. As you see here, lat long, every increase in the lat long causes a decrease to the house value. Pretty interesting. Lastly, I wanted to show you how to test your machine learning model on a test set, right? With my data set I didn't have just one train and one test. So I had a test set and then a training data set. So I just tested all my whole data set, and you see here that you could see the prediction next to it. So as you see here, it's using the evaluate method to evaluate it, and then also the predictions method to show you the predictions of each one. My my R squared was pretty not so good, so it's 62% accuracy. So this is also the metrics you could get from the PySpark ML module. And I believe that is it. Thank you for watching. I hope you saw how PySpark could how easy PySpark is to use and how easy it is to launch it on a cluster compute as well, using your original using on your local machine first. And this could also help, if you have a very big data set. So thank you for watching. I hope this was helpful for you.